Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cindy.
I'm Emily. For math homework, help call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media.
Nicely done. Thank you for that, Emily. So where do you go to school?
I go to school at Highgate Elementary.
That's a pretty new school, isn't it?
Yes.
Have you been there for a long time?
This is my second year.
So you're in second grade?
No.
No? Oh, what
In
grade are
fourth.
you in?
Fourth.
You're in fourth grade, all right. So where did you go to school before that then?
I went to Old River Elementary.
All right. And so you've been at each school, I think, for 2 years now, right, if you're in fourth grade?
Yes.
Do you have a favorite school?
No, both of my schools are pretty nice.
Well, good. That was a nice way to answer that right there. What is the best thing you like about Highgate right now?
It's kind of nice that we rarely get silent lunches.
Oh, you like that?
No, it's rarely.
Oh, it's rare that you, oh, okay, all right. So silent lunches. So what goes on with that? I don't.
Whenever the kids are too noisy, it's not nice to have a silent lunch, but it's nice to not have the teachers yelling at you through the microphone.
All right. And are you one of the causes that you guys have silent lunches?
No.
Okay, well, that's good. But everything's going well with fourth grade so far this
Yes.
year? And how's the math been?
I've been doing pretty good. A couple of times I'll get a problem wrong, but then I'll start to learn it better. Sometimes my parents will help me understand the question better. So I get better at whatever we're working on in class.
Good. Well, I'm glad that you have a positive outlook on it. And if you happen to get something wrong, that's fine. You can always work on it and get a little better at it, right? Because do you know what happens every time you get a problem wrong? Your brain grows, right? So by making mistakes, you're actually getting smarter by making that mistake. So it helps you out, right?
Yes.
Because we're going to make mistakes for the rest of our lives, right?
Yeah.
All right. You ready to help me out with today's social media problem of the day?
Sure.
All right. Let's take a look at it together. It's going to be up on the screen. So it says, what is the answer? So can you read that for me?
63.85 times.
Something, right? They just
Yeah.
have some parentheses there, right? And it equals what? What does that equal?
63,850.
Good, right? Because sometimes when you get a lot of numbers, right, a lot of digits in there, it's kind of hard to all right, how do I word that again, right? So 63,850. And you did nice with the first part, 63.85. Do you know if there's another way to read that instead of saying 63.85?
No, I do not.
Okay. Have you heard of fractional parts and decimals where you have numbers like that, 63.85, like the numbers after the decimal, what those are called? Like tenths, hundredths, thousandths. Have you done that yet in school?
No, we have not.
All right, excellent. Well, you're going to learn a lot today there, young lady. All right, so that is 63 and 85 hundredths. All right, and you and Cindy will go over a little bit of this later on. So which one of those do you think we're going to put inside the parentheses? So basically we have 63 and a little bit more, right? So just think about it as 63, okay? And we need to get to 63,000 and a little more. So we're going to need to multiply by 10, 100, or 1,000. Which one of those do you think?
I'm debating either the 10 or the 100.
Excellent to debate that right there. So why do you think the 10?
Because how we learned multiplication, if we did kind of like our square root, maybe it could give you 63 63,850, but then also the 100 could have a chance to give you that answer as well.
Okay. So you don't think 1,000 could have anything to do with it?
No, because
Okay.
then that just gets it a bigger number.
This gets it a bigger number. All right. So let's try this. If I had 1 and I had to get to 1,000, what would I multiply by?
Probably 1,000.
1,000, right? If I had 4 and I wanted to get to 4,000, what would I multiply by?
1,000.
Okay. So do you get where I'm going so far?
Yeah.
All right. If I had 23 and I wanted to get to 23,000, what would I multiply by?
1,000.
If I had 23 and a little bit, what would I multiply to get to 23,000 and a little bit?
1,000.
So we're seeing a pattern, right? Okay. So the decimal point is 63 and a little bit. Okay. Now, if there was no decimal point there, it'd be pretty easy to do, but we have to deal with this. All right. So we're going to move the decimal point to the right 2 places. So it's going to go at the end of the 5. So if I move the decimal place between the 3 and the 8 to the end of the 5, how many places will I move it?
2.
2, which is going to be the same as 2 zeros if we're thinking about it in
Yes.
decimals and powers of 10.
Yes.
Does that make sense?
Yes.
Okay. But when we look at 63,850, how many numbers are after the 5 now?
1.
1. So instead of just adding 2 places, I have to add another place, right?
Yeah.
So instead of just adding 2 places, I need to add 3. Does that make sense?
Yes.
Okay. So instead of just adding 2 zeros, like in 100,
Yeah.
what do I need?
You need to add 1 0.
I need to add another 0, right? So instead of 2 zeros in my answer, I'm going to need 3. So think about it again, right? If I have 23 and I want to get to 23,000, I multiply by,
1,000.
okay? So think about it this way. I'm at 63 and I want to get to 63,000. What do I need to multiply by?
1,000.
1,000, all right? So right now it's 63,850 if we do it like that, because we're going to take the decimal point and we're going to move it 2 places, but we need to add 1 more 0, so that means we have to move it 3 places altogether.
Got it.
So we have 1s and 0s in all of our options. So which one do you want to go with, A, B, or C?
Maybe B.
Maybe B, all right. Because remember, we need to move over 3 zeros over, right?
Yeah.
So which one has 3 zeros?
100. Well, it has 2 zeros.
It has 2 zeros, but how many zeros do we need?
3. So honestly, I think it might be 1,000.
So you honestly think it's 1,000 now? All right. Now, at first you said between 10 and 100, and you felt pretty good about that.
Yeah.
And you said 1,000 couldn't be in there.
Yeah.
But now you say honestly it's 1,000.
Yeah, it's a little confusing to me because I don't know. So I have, of course, 63,085, but I don't know if I want to do 10, 100, 1,000. They're all possible answers. But really, I think I need like a piece of paper to work it out.
Excellent. And you know what? You're going to be able to do that a little bit later on. But for right now, do you want to go A, B, or C? Because C you said had the 3 zeros, and that's the one you said honestly was your answer. So you still want to stay with your C of honestly C? Because I think that's a pretty good option because we need 3 zeros, right?
Yeah, maybe.
Which one has 3 zeros?
1,000.
1,000. Let's take a look indeed and see if 1,000 is correct. All right, there we go. 1,000 is correct. See, the first problem took a little bit, right?
Yeah.
But we kind of got through it, and that's going to be something that we're going to work on today. Sound
Got it.
good? So that way, when you do that in class with decimals, you're going to be all over that.
Got it.
All right, good. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, today's Math in the News has to do with happy birthday. Yeah, now you're like, all right, old man, what's going on with the happy birthday thing, all right? So what are the odds? So a lot of times people work and they go, all right, you know, whose birthday is when? And occasionally you run into somebody and you're like, God, it's the same birthday as me. So what are the odds? Well, the odds of 2 people having the same birthday are 1 out of 365. And every 4 years you can go, it's 1 out of 366 because of the leap day. But that's about 0.25% So this problem is known as the birthday paradox. The probability of two people sharing a birthday increases as the number of possible pairings increases. So you could always look this up, but it's been proven time and time again. If you have a group of 23 people, there's a 50-50 shot that you share a birthday with somebody else in that group of 23. So you have a 50% chance with only 23 people. So we're going to take a look at a graph right here and show how this is represented. So the number of people, as it increases, obviously your probability of having a birthday with somebody increases also. But we're interested in when will it match one other person. So you need to have a 50% chance, which is when it comes over, and you can see that is at 23 people. That is when you're going to have a 50% chance of sharing a birthday with somebody else. Now, on the board we have what is the probability, the percent that 3 people have it on the same day. And the reason we brought that up is because on the next slide, we're going to talk about 3 people in our office that actually have the same birthday. And one is Mickey, one of the tutors here on Do the Math. And all of their birthdays are today. Denise, who does all of our graphics for Do the Math. So every time you see Do the Math and something's going on with it, social media or whatever, Denise is the one that helps out with all of the graphics. And Merrill Clinton, is one of our higher executives here at the Kern County Superintendent of Schools. So we want to say happy birthday to Mickey, Denise, and Merrill. 50% shot that 2 of them had a birthday. Pretty good that all 3 of them had the same birthday on today, January 28th. So from all of us that Do the Math, and if you have a birthday out there today also, happy birthday from all of us that Do the Math. That is today's Math in the News. We'll be back with more right after this.
Hi, my name's Sloan, and today I'm going to be explaining the Pythagorean theorem. The Pythagorean theorem is a formula that's used when finding the missing side length of a right triangle. The formula is a squared plus b squared equals c squared. For my first example, I'm going to be showing you guys how to solve for the longest side of this triangle, and the longest side is called the hypotenuse. And the hypotenuse is always c squared. So since we don't know what this number is, and this is c squared, we're just going to plug in these 2 numbers for these variables. And it doesn't matter which one it is. So we're just going to plug in 3 for A, 4 for B, and they're going to keep C a variable because we don't know what it is yet. So then we're going to square these numbers. So I'm going to move it down a tiny bit. So 3 times 3 is 9, 4 times 4 is 16, equals C squared. So then we're going to add these 2, and we get 25 equals C squared. And then we're going to take the square root of both of these numbers, and we get left with our final answer, which is 5 equals C. So we know that this missing side length is 5 inches. So then for my next example, I'm going to be teaching you how to solve for a missing side length that's not the hypotenuse. So we're going to plug in 8 for A, so we're going to do A squared, that's a bad 8 squared, plus, and then we're going to keep B a variable because that's the missing side length. B squared equals 10 squared. So then we're going to square these numbers. So we get 64 plus B squared equals 100 because 8 times 8 is 64 and 10 times 10 is 100. So then we're going to subtract 64 from both sides to balance out the equation. So this cancels out 64, and then we're left with B squared equals 36. And just like we did on this problem, we're going to take the square root of both of them, and that eliminates the exponent, so we get B equals 6. So that's how we know our missing side length is 6. And that's all for today. Thank you.
And thank you to Sloan right there, and a little bit of Let's Talk Math. In studio, we have Emily, a 4th grade student from Highgate Elementary, and just loving everything at Highgate right now, right?
Yeah.
What is your mascot? The Highgate, what are you guys like?
Huskies.
Huskies. That's right. I was trying to think Hawks or something like that, but it's the Highgate Huskies. You like Huskies or Hawks better?
Huskies.
You like Huskies better?
Yes.
If you had to have, they said, Emily, we're going to change from the Huskies. We're not going to be Huskies. What are we going to be from now on? The Highgate Emily's? No. All right. The Highgate what?
I'd say the Huskies. I'd like it way better.
So you like the Huskies better than the Hawks, huh? You're like, old man, I don't know what you know talking about the Hawks like that. We aren't the Hawks. You ready to do some more math?
Yes.
All right, I'm not even going to call you Emily anymore. You're Giggles today, all right? Over to the board, young lady. All right, so Emily, I want you to work with Cindy on decimals and moving the decimal to different powers of 10. So maybe we'll start with like 2.
Can we start with the whole number just to get the 10 thing down?
And let's start with 23 since we're in our
All right.
23rd season.
All right. 23rd season, we're going to start with 23. All right, so 23, no decimal in it yet, right?
Yeah.
If I said this, would you know the answer?
Yeah. Can I work it out?
Well, yes, work it out, but do you know it without working it out? If not, that's okay. I'm just asking first.
No, I think I need to work it out.
All right, let's see what happens. Then maybe you'll notice what's going on. So you're going to do the area model, I think they call that, right?
Mm-hmm. $230.
Okay. So what do you notice about this answer compared to these numbers?
Well, by 10, it will increase it to like 100.
So it just like, basically like you don't see a decimal, it means it's here, right? Do you know that? Think of money, $23,
Yeah.
23.00, right? So there's an invisible decimal, so it went like this. Okay? So what if we did, what do you think would happen if we did this?
It'd be 23,000.
Do you want to write what you think it would be? Write what you think it would be. Okay, so now read that to me again.
2,300.
Good. Because you said 23,000, but
Yeah.
you meant 2,300.
Yeah.
What if I did this?
Then it'd be
Okay, so you're seeing a pattern, right?
Yeah.
What's happening?
the zeros are increasing. So
Yeah.
it went from 1, 2, and 3.
Okay. So, and then I showed you in the very beginning, like there's an invisible decimal and
Yeah.
it technically moved because of that power of 10. All right, so now let's try one with the decimal. So let's try this. Do we want to erase it or just, we could probably fit at least one in here, right? Let's try this. We'll still stick with our number that
Got it.
we're kind of used to. What do you think will happen right there?
I think it'd still be the same answer, but then we just put a decimal there.
Okay. So if this was money, do you know how you would read it?
$2.30.
Okay, and how would you read that?
$2 and wait, no,
You're right, this would be $2.30.
probably $23.
And that also would be, right? Yeah, so what's gonna happen is because we're multiplying by 10, it's like we're taking 10 of these $2.30.
Yeah.
And all it really does is make the decimal move based on the power of the 0, which is a power of 10. So 1 0 moves 1 time. So 2 zeros technically moved it 2 times. And then 3 zeros, how many?
Moved it 3 times.
Yeah, so if we had this, what would happen? How many times should it move?
It should move 3 times.
Okay, so write out what would it be. Okay, so what you did was add on 3 zeros. You told me it should move 3 times.
Yeah.
So I want you to like go back to where the decimal was originally and then kind of do like I showed right here somewhere. Oh, right here. How it kind of moved.
Yeah.
Show me where it would move to if you counted 3 spaces. So starting from right here.
It moved to here.
So how many is that?
1, 2, 3,
So
4.
you went
well,
4. How many did we want? How many
3.
zeros were there? Yeah, so we needed like, take that one out. So it'd be 2,300.
Got it.
So what if it was, how many zeros are here?
Maybe there's 2 zeros there.
So if you start with a regular original number,
Yeah.
how many times do you want to move that decimal?
Maybe 2.
So what would happen to it?
I think you had 2 zeros.
So just physically move it and then add your zeros based on like how many you need
How do
to
you
fill it
move
in. So like go 1, and then what?
2.
Okay. So you moved it 3. Do you want to move it 3?
No, I just want it to do for my 2 zeros.
So you're thinking of like up here how we added 2 zeros
Yeah.
on, but that's because we didn't have any decimals in between.
Yeah.
So when you multiply by 10, it bumps it over once and you get just 23 right here. When you multiply by 100, it's going to bump it twice. So it's going to end up right here and there'd just be 1 0 that
Got
you
it.
need. Technically,
Right, and I
there's an
think the
invisible
good
zero.
thing, Cindy, is actually having her physically move that decimal point instead of just thinking about it. So I want you to do a couple more, maybe do 2 more, where Emily, I want you to actually put your marker on that decimal point and make the little loops, how many zeros there are, and whatever loop
Got it.
is empty, that's where the zeros go. So by physically doing it,
I'm gonna
it's
erase
going to
this
help
because
you out,
see
I
you
think.
look at it. And I want you to think about
Yeah.
like I want you to just look at the problem you're on. Okay, let's try a different number besides 2.2.
Got it.
Let's do like, what do you want? 4 point. You're in 4th grade,
Yeah.
and it's what month of August, September, October, November, December, January? 4.6. 6th month of the year.
Yeah.
Times what? 10, 100, 1,000. Which one do you want?
10.
Okay, start with 10.
So I think you.
So explain to Cindy what you're thinking about.
So I want you to write what I wrote and then actually take your pen like he was asking you
Got
to do and move that decimal. So write 4.6, so the original number, which would be like...
Right there?
Yeah. Go ahead and write it right there. And then put your point where it started. Okay, now you're going to move it. How many times? So how many zeros are in that?
1.
Okay,
So I
show me
think-
how it would move one time. So what would you get?
4.6.
Well, you moved it though.
Oh.
So it ends up as like that, technically, right? So what is that?
46. Just 46? Yeah.
Because there's nothing else, right,
Oh,
to say,
yeah.
technically, right?
Yeah.
If there's money, you'd put zeros, but you don't really
Yeah.
have to. Okay, how about, what do you want, 100 or 1,000?
Yeah. 100.
Okay. Okay.
So we got 4.6.
Okay, so you got your 4.6. And how many zeros are there?
2.
Okay, so how many times do you want to move it?
Probably 2.
Okay. So show me what that would look like. With your pen, actually move it. Like
Got it.
draw the.
1, 2.
Okay. And then you fill in the empty space.
With the 0.
Okay. And now the decimal's here. So it would just be 460.
Got it.
Because that would be gone, moved.
All right, good. So that was a couple more. So we'll keep on working it a little bit. But Emily, do you like ice cream?
Yeah.
Do you have a favorite flavor of ice cream?
I like basically all the flavors.
You like all the flavors. Do you like trying out new flavors?
I kind of like to stick with like the normal flavors because like sometimes, like they're a little wonky.
Yeah, sometimes they get real wonky, right? But you know what? Sometimes wonky ones are pretty good too. And you're going to be able to go to Sweet Fix and get an ice cream, whatever kind you like. And they do have some regular ones, and they have some wonky ones over there too. So congratulations on that. You've got yourself a scoop over at Sweet Fix Creamery. We'll be back with more right after this. And in studio with us, we have a 4th grade student from Highgate Elementary, Emily. Oh, I'm sorry, Giggles. I got you on that one, didn't I, Emily? Huh? Everything feeling pretty good?
Yeah.
All right. So that decimal thing, multiplying by tens, hundreds, and thousands, can kind of get a little bit tricky, but it seemed like you kind of got it a little bit as you went
Yeah.
on. And I know you're in 4th grade, but when you're in 5th grade and 6th grade, you're going to do that a lot. So hopefully you kind of understood it a little bit, and then when you start doing it a little bit more, you'll go, oh, that's right, I remember Cindy and that old man was showing me that stuff, and I remember kind of some of that stuff right there. But since you like to giggle, you know what? There's a lot of people that like to laugh about riddles. All right, young lady, you ready to help me out with this riddle?
Yeah.
All right, so go ahead and read that for me.
If 2's company and 3's a crowd, what are 4 and 5?
Okay, have you ever heard the saying, 2's company, but 3's a crowd? Have you ever heard that saying?
No, I've not.
Okay, as you get older, you will come across that, and they'll go, hey, you know what, 2 company, but 3, that's a crowd, all right? Anyway, it's a saying, so anyway, we just think about it mathematically, right? If 2's company and 3's a crowd, what are 4 and 5? Do you have an idea?
No, I do not. It's kind of hard.
It is kind of hard, isn't it? All right, so remember, we're doing a riddle, so it might be a little more straightforward than we might be thinking about also, okay? So what is it eventually asking us for?
Like to figure out what is 4 and 5.
Good. And if somebody just didn't even say the other part to you, right? They said, hey, Emily, what's 4 and 5?
I'd be a little confused because I was like, what are you comparing it to?
Well, just what's 4 and 5?
Really a number?
What's 1 and 1?
A number?
Okay, what number is it?
It's 1, like the first number.
Okay. But if I had 1 and 1,
Then it'd be 2.
okay, what'd you do?
I just added them together.
Okay. What's 1 and 2?
1 and 2 is 3.
Okay. What are 4 and 5?
You add them together, like from.
I don't know, it's a riddle, you gotta help me.
I
What
don't
are
know.
4 and 5? I have 4 and I have 5. What are 4 and 5?
9.
Okay, so let's think about it again. If 2's company and 3's a crowd, what are 4 and 5? Aren't 4 and 5 9?
Yeah.
Okay, but there's going to be a lot of people that go, I don't know, what is, like what's 4 and 5? Like 3's company, 4 is a crowd, 5 is a mob, right? 4 is like a gathering or something like that, right? They're trying to think of different ways to say groups of things, right? But all it is simply the number 4 and 5, right? So read it and then tell us what the answer is.
If 2's company and 3's a crowd, what are 4 and 5?
And what are they?
5's mom.
5 is a mob, isn't it? But what did we say as far as the number goes? What's 4 and 5?
A group.
A group it is. But if we add them together, what do we get?
9.
All right, so let's take a look and see if indeed it is 9. 9 it is, there you go. So that's a riddle, right? Because it's a different way of thinking about it, a different way of wording things and stuff like that, right? So hey, 2's company, 3's a crowd, what are 4 and 5? And you go, hey, wise guy, it's 9. Right? There's no such thing as 4 and 5 like that. All right? Now, in class, what have you been working on?
Equivalent fractions.
You like equivalent fractions?
Yeah.
Okay. I'm glad they make you happy. You ready to show Cindy how to make equivalent fractions?
Yeah.
All right, go to the board there, Giggles. Let's go. All right, so Cindy, right up on the board, 2 over 3. And Emily, I would like you to explain to Cindy anything and everything you know about equivalent fractions right now.
So
And you can write stuff down if you need to, but
equivalent fractions is where you get a fraction and then you can either multiply by 2 or divide it by 2 to get another way of, like, it's
Represent.
equal to, of what really it's equal to 2 over 3.
Okay. So show me one of them. Show me an equivalent fraction.
So
to
you
2/3.
can multiply it by 2.
Oh, so you have to multiply both parts by 2, right?
Yeah.
Okay.
And you can get 4 over 6.
Okay.
And then another way is, I don't know if you can divide this one by 2.
Well, 3 is not divisible by 2 evenly, correct?
Yeah.
Could you maybe multiply it by something else? Do you think that would work, other than 2?
Maybe I can do it by 4.
Okay, try that.
Eight over 12.
All right, and you know what I just noticed?
What?
That if you multiplied this by 2, what would you
Yeah.
get?
8, 12.
Yeah, so they must be equivalent then, right? They're all equivalent? Okay.
So Emily, do this for me. Write 2/3 again. And just put a 0 after the 2 and a 0 after the 3. Are those equivalent to 2/3?
I'd say yes.
Well, could
Do
they
you
have
say
multiplied
yes or
that
do you
by?
know yes? So Cindy, just do that one problem. Just do 2/3 and see indeed is equivalent to 20 over 30. And after that, we'll
So-
move on.
Basically, you're trying to figure out if you could make this, well, that's not there, pretend, right? Okay, if you could make that with something, what could you multiply this by so that you end up with that?
10.
All right, write it out, let's see. All right, 2 times 10 is?
20.
3 times 10 is?
30.
So 20 over 30
Is
is equivalent
equivalent.
also.
So what I wanted you to do, Emily, was see that instead of having to actually write down multiply by 10 over 10, all you had to do was add a 0 at the end of the numbers, right?
Yeah.
You ready to check something out?
Yeah, sure.
Where you have 20 over 30, put another 0 at the end of both of them. Is that equivalent to 2/3?
Yep. Because
Why?
you just had another 0 here, and it's 2/3 over 100, and 2 times 100 is going to give you 200, and 3 times 100 is going to give you 300.
So if somebody said, I want you to make 18 equivalent fractions, instead of multiplying a bunch of different things, you could just keep adding zeros, couldn't you?
Yeah.
There you go. Just another little thing for you to think about right there. 636-4357 is that phone number. We'll be back with more right after this.
This is the Discovery Files from the U.S. National Science Foundation. Today we are joined by Dr. Joanna Schisler, and she's going to explain what a virus is.
So I like to define viruses as very small particles that are consisting of genetic material, so genes, that are protected by a protein-based coat. Kind of protects the RNA and the DNA. The genetic material that some viruses have is DNA, so that's something that you and I have that makes up our own genomes. Other viruses have RNA, and that's a little bit different. So what you see is a really amazing variety of viruses when it comes to shapes and sizes. We're starting to get an appreciation for how viruses can actually be helpful to us as humans. So we used to think of viruses as very rare things that would happen to us, right? So normally we don't have any viruses except for when we come down with a cold. What we're starting to understand is that actually there are a lot of viruses that are in different parts of our body and at different times. And so there's estimates that there are around 380 trillion viruses either inside or on the surface of our bodies at any time. It's really fascinating because we're thinking about trillions of viruses, and when you think about our own microbiomes, you're thinking about billions of bacterial cells. So when you think about yourself as a whole, there's actually probably more viruses and bacteria than there are human cells that make you up. There's only a few ways that viruses can spread. With COVID, we've learned about respiratory droplets and how important that is. So if you're thinking about how to protect yourself from respiratory viruses, then you want to think about, covering your cough or wearing a mask or sneezing into a tissue and then throwing that tissue away. Viruses can also be spread by the fecal-oral route. Viruses that replicate in the intestine and come out in feces and then people are not very clean with their hands and they'll then put their hands to their mouths or their eyeballs. People are now working on being able to collect viruses from the air. They talk about the air virome to be able to detect what's in the air. So I think we're at an amazing time where we can sample and also detect viruses at a very early stage, even before humans or other animals become sick.
Important to know all year round, but especially during this time of the year. Time now to take a look at a little math around the world. And in studio we have Ava, a student at Berkshire Elementary. How are you today, Ava?
I'm doing good.
And what grade are you in?
I'm in 6th grade.
All right, and you had an assignment where you had to take a look at mathematics from a different culture. And what will you be talking about today?
I'll be talking about how the Mayans did math like in the past.
All right, well, as soon as you're ready, Ava, let's hear what you've got.
Okay. Slideshow by me. So first up, we have the Mayan numerals. Each different symbol has a value. The dot has the value of 1, the bar has the value of 5, and a shell has the value of 0. They purposely ordered it so that each layer would have some sort of different value. So, for example, for the ones place, you would have two dots, so that would equal to the number 2. And whenever it says 20s place, it means each one would be like the value of 20. For example, 5 plus 2 equals 7, so you would do 7 times 20 to equal 140. The Mayan people, similarly to the Americans, they would do like math with the symbols, much like our numbers, but just with the symbols they used. So we have 5 plus 8 equals 13. As you can see, it's symbolized by the things that they used around them. Fun facts. The Mayans did not actually have multiplication or division. They just used repeated addition or repeated subtraction to use the same effect. They had 2 numeric systems. One for the priests, because they were higher ranking, and one for the normal citizens. The addition and subtraction symbols were very closely similar to the American ones. And their math highly benefited them in terms of whatever they did. Change society by providing a way to do math. This helped them create a calendar, figure out when eclipses will happen, and help with agriculture cycles, and organize religious ceremonies. This benefits them by keeping events organized and in place. In summary, this is the basic overview of how the Mayans solved math problems. This math system carries on in the American base 10 equations. In modern math, they use one small square for 1, one long stick for 10, and one big cube for 100. The end.
All right, well, nicely done, Ava. So I know that you probably didn't have a choice on what culture you did. I know that sometimes you just are given those things. So what did you like most, or what did you find most interesting about the Mayan mathematics?
I think what I found most interesting is that how it impacted to today's culture, like how most of the system is very similar to the system today, like how it carries on.
Okay, and is there anything that you like? I mean, because there's a lot of dots and bars and things like that. Do you think you would find that easier to kind of learn if you had to do something like that?
I think I would find it easier. I think the only hard part would just be having the order, but
Otherwise, I think it would be a little bit more easier than the normal base 10 that we use today.
All right, good. Well, now that you've had a little experience looking at the Mayan mathematics, are there any other cultures or civilizations that you can think of that you might find interesting to find a little bit more out about?
I think I would like to know how maybe Egyptians did math.
All right, well, good. Well, you know what? Maybe you can do a little research on Egyptian math and possibly we'll have you back on again. So, Ava, thank you very much for coming in this afternoon and sharing your expertise on Mayan mathematics on today's Math Around the World. We'll be back with more right after this.
What is an aurora? An aurora looks like a beautiful display of lights in the sky. These are some auroras that were spotted in the sky over central Alaska. We can also see auroras from space. This is what an aurora looks like from the International Space Station. The name of an aurora changes depending on its location. If you're in the northern hemisphere, it is called aurora borealis, or northern lights. And if you're in the southern hemisphere, then it is called aurora australis, or southern lights. So, what causes these beautiful displays of lights anyway? The sun. That's right. Even though auroras are best seen at night, these colorful displays are caused by our ever-changing sun. How exactly does it work? Well, the sun is constantly sending heat and light to Earth. It also sends other kinds of energy in small electrified particles too. This is called the solar wind. Earth has a magnetic field, which protects us from most solar winds, but it also traps some of the electrified particles in the space around Earth. The sun does not always send the same amount of energy. Sometimes the sun has huge outbursts and blasts more stuff into space than the usual solar wind. These events are called solar storms. During one kind of solar storm, called a coronal mass ejection, the sun burps a massive bubble of gas that pops and sends particles and energy zooming through space. When a solar storm reaches Earth, it dances with our magnetic field, and some of the energy and particles that zip around the magnetic field dive into our atmosphere near the North and South poles. The particles then bump into gases in our atmosphere. These interactions result in displays of light in the sky, auroras. When the particles bump into oxygen in our atmosphere, the reaction makes green and red light. When the particles bump into nitrogen in our atmosphere, it makes blue and purple light. Earth is not the only planet with auroras. If a planet has an atmosphere and a magnetic field, it probably has auroras. For example, NASA spacecraft have captured amazing auroras on Jupiter and Saturn. Learn more about our planet and our solar system at NASA Space Place.
In studio with us, we have fourth grade student Emily from Highgate Elementary. That stuff about NASA, are you interested in space at all or anything like that?
Not really, but I think the Northern Lights is pretty neat.
Oh, it is. Have you ever seen the Northern Lights?
No.
Well, that might be something that you can do a little bit later on in life when you get a little older, and who knows, you might be able to have an opportunity to go check out the Northern Lights. I think I'll do that too.
Okay.
I hope you get to go there first, though.
Got it.
All right. You ready to do some more math?
Sure.
All right, back over to the board, young lady. So, equivalent fractions you felt pretty comfortable with.
Yes.
And we showed you some things how you could do them a little simpler instead of multiplying by something all the time.
Yeah.
So we're going to take a look at simplest form now. So, Cindy, let's go 6/8. And Emily, talk to Cindy about what you know right now, because I think you just started talking about this in school.
Yes, just
What
today.
you know about simplest form, and then what you think you're going to do.
What I know about simplest form is basically you get a fraction, and then you try to get, and then you get it to the smallest fraction you can that will be equivalent to the fraction problem that you have.
Okay. So how would we approach it?
You could maybe divide something by it.
Okay. So if you have 6 and 8, and you're trying to divide it so that you can simplify it, what do you know you can divide?
Maybe I think I'll try dividing it by maybe 2.
Okay, let's do it. Okay, so what I notice is it's just kind of the reverse of what you were just doing earlier.
Yeah.
Okay, I like it.
So can that become any simpler?
I'm not too sure because 3 you really can't get an even number out of it, but 4 you definitely can divide it. I'm not too
So
sure.
3 is only divisible by itself, and
Yeah.
1, yeah? And 4 can't divide by 3, can divide by 1, but that doesn't change anything.
Yeah.
So then that's going to be as simplest as it can get.
So have you ever heard of prime and composite numbers?
Yes, we were working on those not last week, but 2 weeks back.
Well, explain to Cindy what prime and composite numbers are a little bit, and if you need some help, the both of you can discuss it a little bit.
Prime is a number that can be multiplied or divided only by 1 itself, and composite is a number that has various ways how to multiply or divide a number.
Okay. So 3 is what kind of number?
It is prime,
And 4 is?
composite.
There you
So if you have one prime and one composite, you know it's already at the simplest form.
Yes.
So let's try this, Hotshot, because you feeling pretty good?
Yeah.
12 over 18.
This one, I think I'm going to try to. There's a couple ways I can divide it, but I think I'm going to start with 2.
Okay. All right, so now let's check your answer. Do you think you can simplify it some more?
Yeah.
Okay, what are you going to divide those by?
I think I can divide it by 3.
Okay, go ahead. All right, now, can you divide that at all or simplify that at all?
Nope, because it's already probably simplest because this number can only be, it's a prime number, it can only be divided by 1 itself. 2 is a composite number.
Is it?
Well,
What can it divide by?
You know what? It's a prime.
Yeah.
So you can't divide it any lower.
Okay, so that's the simplest it can get.
Yep.
Yep.
So Emily, at the beginning you said that there was 12 over 18, and you said there's
Yeah.
a couple of ways you could divide that. So
Yeah.
what else were you thinking of?
I was thinking of
Because
I
you
was
divided
thinking
by
maybe-
2.
yeah, and 3. I was thinking, I'm not too sure about 18 about 4, but I was thinking about maybe by 4 for 12.
Okay, so that was another way to think about it, right?
Yeah.
You would have tried 4 and you would have gone, it didn't work, right? So
Yeah.
it's always good to start with the 2.
Yeah.
What is 2 times 3?
2 times 3 equals 6.
Okay, so write 12 over 18 again.
Is this okay?
And divide each of them by 6 this time instead of the way you did it before.
You can leave that. I was just your shirt touched it, but it looks like a division. So divide by 6.
And get 2 over 3.
And then you got it the first time, right? So this is where he got 2 times 3.
Yeah.
Because you had a 2 and a 3, and you just put it together to make it a 6 right there.
Yeah.
All right, so you're doing well so far. You're feeling pretty good with that simplest form? All right, erase the board.
Go ahead, erase that side.
You ready for one more?
Yeah.
How about 9 over 18?
All right, let's see. So as you think about it, try to come up with the biggest one you can think, because you'll get to your answer quicker. But if you can only think of something, just start with it, whatever you can think of.
My biggest one? Honestly,
What can you think of? Just start with whatever you're thinking.
2 won't work because 9's uneven.
Okay. What does divide into 9?
3.
And what else? 3s?
Yeah, 3's, and then what else?
All right, let's start with 3. Okay, does 3 also divide into 18?
Yeah, by 6.
Okay, so you can start with 3. Okay,
over
so
6.
now I want you to check your answer and decide if you can make it simpler or not.
I do not think so. 6, I can totally make it simpler, but I cannot by 3 because it is a prime number and it can only be divided by 1 itself. So
Okay.
I think.
So I like the way you're thinking. The only thing I would say is also check. So you're right, 3 can only divide by 1 in itself, but could the number itself divide into 6?
Oh yeah, I can.
So
by
that
2.
means you can go a little bit further. So divide them both by 3. 3. 2 is what you're going to get. Yeah, 3 would be what you divide by. So divide them both by 3. Because even though it's a prime number, write a 3 right there.
3?
Yeah. 2 is going to be what you get out of it. Just make it look like a 3. There we go. There. Okay. What's 3 divided by 3?
And then that is going to equal 1, and that's going to equal 2.
Okay.
So actually,
So in the very beginning, when I said try to think of the biggest thing that you could think of, since we ended up using 2 3s, what's 3 times 3?
3 times 3 equals 9.
So we could have said divide by 9. Divide by 9. What would you get?
1
Over.
2.
Yeah. So it's not always has to be an even number, right? It can be the number itself sometimes. It could be a 3 sometimes. It might be a 4. It might be a 2. You can just whatever.
So that's a strategy, is
whichever
always look at the number on top and see if it will automatically go into the number on the bottom. You ready to try one more?
Sure.
5 over 15.
We can write it right here.
Automatically, I'm thinking we can divide it by 3. Well, actually, no, because of the 5.
What's 5 divisible by?
1.
And? What kind of number is it?
It is prime.
And you told me earlier that prime was a number that can only divide by itself and 1.
And 1.
So what can 5 divide by?
Itself.
Okay. Which is,
5.
can you divide the bottom, the 15, the denominator, by 5
Yes.
also? Okay. There you go. Yeah. So what Mike was saying earlier is if you notice that 5 divides into 15, then that means you can start with that number.
Got it.
Like right here, 9 divides into 18, so you can start with 9. So you should check
There
that
you go.
first.
Nicely done. Come on over here, Emily. So you've done quite a bit of work today, right?
Yeah.
I mean, a little bit of stuff that you're doing in 4th grade, but we made you do a little bit more stuff that you're going to be doing later in the year and
Yeah.
even next year, right?
Yes.
So what'd you think of that?
Like, I'm okay at it, but like once we learn in class, I'll understand it more.
That's the whole point of it right there. Did you know that you are now an ambassador for Do the Math? You know what that means?
No.
An ambassador means you are a representative of Do the Math. So as a representative of Do the Math, you would probably need a uniform, correct? Mm-hmm. And we gave you a uniform today.
Yeah.
That t-shirt, right?
Yeah.
So do you know when you have to wear that t-shirt?
No.
Every day. No, not every single day, but a lot of times, right?
Yeah.
So when you wear your t-shirt, let's say you wear it to school or something like that, and
Yeah.
people are like, hey, Emily, what's up with that nice looking shirt there? It says Do the Math. What is that? Are you going to be able to tell them about Do the Math?
Yeah.
That's all we need you to do. It's that simple. So you're going to be a good ambassador for us?
Yeah.
I know you will. Have you ever seen one of these?
Yeah, Rubik's Cube.
Rubik's Cube. Are you a master of this? You know how to do this thing?
No,
Have you ever done one?
not really.
Neither have I. But you know what? Because you're an ambassador for Do the Math, you're going to get the exclusive Do the Math Rubik's Cube. You all cool with that?
Yeah.
So it's just something to play around with. You can try it out, see if you can solve it, and it's just something to take your mind off of other things. Take your mind off math by doing some math. Feel good?
Yeah.
All right. I'll be right back because you know what we're going to do. You said you liked ice cream, right?
Yeah.
All right. So, breakfast for ice cream. Have you ever heard of that?
No.
Well, it's something happening. It's happening this Saturday at Sweet Fix Creamery. It's right on Coffee Road, right next to Trader Joe's. So it's happening this Saturday, February 1st from 9 to 1. So I know you're like, 1 o'clock, breakfast. Well, some people get up late. So anyway, it's 9 to 1. Breakfast is going to be at Sweet Fix Creamery because we're having ice cream for breakfast. If you've never been there, you definitely want to go check it out. They have some of the regular flavors like Emily likes and a lot of other people do. But they have like, I think you said wonky flavors?
Yeah.
Right? All right, well, good. You know what? They have wonky flavors. They have a lot of different types. So you want to go check it out. Breakfast with ice cream for breakfast, all happening at Sweet Fix Creamery. Emily, you've been an excellent ambassador for us. I know you're going to be. Did you learn something today?
Yeah, a little bit of decimals.
Good. Well, you learned a little bit of decimals. I'm glad you brought that up. And did you have fun today?
Yeah.
That's the most important thing because you know what your new name is now, right?
Giggles.
Giggles, right? See, you even knew it. I didn't even have to tell you about that. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.